Hi everyone, my name is Pranav Teja. I am from CSM branch, first year student, B section. Today I am going to present a PPT presentation on a subject LAC, which is Linear Algebra and Calculus. So I welcome you all to my video presentation, and so let's get started. My topic on this math LAC topic that I'm going to present now is on the topic differential equations. Types of differential equations. What are differential equations? So, in order to know them, let's get started. So, what are differential equations? Types of differential equations. Historical background. Differential equations have already been proved a significant part of applied and pure mathematics since their introduction with the invention of calculus by Newton and Leibniz in the mid-17th century. Differential equations played a pivotal role in many disciplines like physics, biology, engineering, and economics. Application of differential equations. Now these differential equations that we are going to see in this PPT is we have many applications on differential equations in variety of various fields in everyday world, in everyday uh, day-to-day life and other fields. In many other fields we are using these differential equations. There are many applications of differential equations. Some of them are exponential decay, growth and decay, population growth, motion of objects declining under gravity with air, resistance and motion of objects hanging from a spring, Newton's law of cooling, particle moving on a curve, electrical circuits, computer science. These are some of the fields where differential equations are widely used, mostly or used frequently, and in exponential growth and decay and population growth, the differential equations are used in these all are basically the generally where differential equations are used widely. So let's get started to actual presentation. This is actually the introduction that I have been telling you what are the differential equations. So what are the equations we are going to deal with in the next PPT, next slide. Okay, so let's go. What are differential equations? A equation that includes at least one derivative of a function is called a differential equation. What? An equation that includes at least one derivative of a function is called a differential equation. For example of differential equations are given below. Here dy by dx is equals to x square minus 10. This is one kind of differential equation. Okay, it has one derivative, which is one derivative. That means it is dy by dx is a derivative. We are going to find the differentiation of this function, this equation. Now this equation dy by dx is equals to now let's look at this equation. Here however if we differentiate this x square minus 10, what we are going to get is 2. No, this is a separate equation and this is one of the another separate equation. I was confused. I thought these two are some related, so I actually got confused. I'm sorry. This is one equation and these are all different equations. These are the derivative. This is the equations where the derivative is 1. Okay, dy by dx is equals to 2x square, dy by dx is equals to x sin x, dy by dx plus y is equals to 16x. These are the different types of equations. Uh, Before proceeding further, it is essential to know about the basic terms like order and degree of a differential equations, which can be defined as. We go into the next slide. Order. It is the highest derivative of a differential equation. For example, dy by dx is equals to 12x square y. Here order is a main plays a main part here. The above differential equation has only first derivative dy by dx. Therefore, it is called a first order differential equation. Let's check. So, what here the first what this is equation means, it has only one derivative. It has order of 1. So, it is order 1. Dy by dx is derivative if it has d square y by dx square. It is the second order derivative. Now let's look at only the first order derivative. We have looked at only first order derivative, that is this. Now going to the second order derivative, let's check another differential equation. D square y by dx square is equal to x1. In this example, the differential equation has a second derivative, i.e. d square y by dx square. Therefore, it is called a second order differential equation. Degree. Now we have looked at order, what is the order, and now we are going to look at what degree means. It is the exponent of the highest derivative of a differential equations. For example, dx by dt is equal to 12x minus 4. In this example, the highest derivative is 1 and the exponent is also 1. Therefore, it is called a first order and first degree differential equation. Similarly, d square y by dx square whole power cube is equal to xy. The what we have seen in the first part of this slide is order. Now what degree means actually is the highest derivative of it is the exponent of the highest derivative of a differential function. Suppose in this equation, this is the highest derivative, dx by dt is the derivative. This exponent of this is 1. So degree of this equation is 1. In this equation, let us see this equation. D square by y by dx square to the whole power cube is equal to xy. This equation, this highest, what is this highest order of this differential equation? That is 2, because d square y by dx square, the order is 2, but the exponent of highest derivative of this differential equation is 3, because the exponent of this highest order is 3. It is power to the power of 3. Here the highest derivative is 2 while the exponent is 3. Therefore, it is called a second order and third degree ordinary differential equation. Let's move on to the next slide. Now let's come to the types of differential equation. This is the actual topic we are going to be discussing. Types of differential equations: ordinary differential equation, partial differential equation, linear differential equation, non-linear differential equation, homogeneous differential equation, non-homogeneous differential equation. Yeah, these are the 6 types of differential equations that we are going to be discussing in this PPT. The first one is ordinary differential equation. It is a differential equation that involves one or more ordinary derivatives but without having partial derivatives. Ordinary differential equation is different from partial differential equation, where some independent variables relating partial derivatives, whereas differential equation has only one independent variable like y. Newton's second law of motion is the simple example of ordinary differential equation. So in this example, this is an ordinary differential equation. The m d square x by dt square equals to f of x. Another example of ordinary differential equation is dx by dt is equals to 12x minus 4. These are the normal ordinary equations which we see in our maths textbooks. We have seen in our high school maths textbooks. Now the second one is the partial differential equation. Partial differential equation is a differential equation that involves partial derivatives. It has two or more independent variables. For example, d square u by d dou. This is not d. This is actually dou. Dou square u by dou x square plus 4xy. Dou square u by dou y square plus u is equals to 2 into dou square u by dou x square to the power 2 plus 4 times dou cube u by dou x dou y square is equal to 10x. The term which you are seeing is dou. It is not actually d, but it is it is called dou, which it is used for partial differential equations. Let us not look into the details of partial differential equations. This is the normal broad way to look what are the differential equations, what are the types of differential equations, what it looks like actually. Let's not look into the detail of this. Let's look at the whole general way. So yeah, the third one that we are going to discuss is linear differential equation. It is a first degree with respect to the dependent variables and its derivative that can be expressed in the form dy by dx plus p or p into x y is equals to q of x, where p and q can be constant or functions of independent variable x. Linear differential equation is, it has first only degree 1. This expression, this kind of expression, this kind of equations has a degree of derivative only one degree it has. That's why it is called linear differential equation. Non-linear differential equation has second order degree, second degree or higher with respect to two dependent variables and its derivatives. For example, d square y by dx square minus dy by dx whole square plus 12y is equals to cos x. So in third one, we have seen that the equation contains only one degree derivative. In this non-linear differential equations, the equation may contain multiple derivatives, degree of derivatives. In this example, d square y by dx square, this is order 2, and dy by dx to the whole power square, this is order, this is of order 1. So these are the fourth type of differential equations, that is non-linear differential equations. Now let us look at the homogeneous differential equation. It is first order differential equation which can be written as y double dash plus f of x y dash plus g of x y is equals to 0. dy by dx is equals to f of x comma y by g of x comma y, where f and g are homogeneous function of similar degree of x and y. For example, dy by dx is equals to 4x square by x minus y. So what this homogeneous differential equation means is, it is first order differential equation which can be written as, this is actually kind of related to first order differential equations, and where f and g are homogeneous functions of linear degree of x and y. Here these are the function of f and g, uh, homogeneous function similar to that of x and y. Let's go to the sixth type of this differential equation. This is the last differential equation that we are going to be discussing, and we will move on to the next slide. That is non-homogeneous differential equation. It is a differential equation whose right hand side is not equal to 0. Uh, a second order non-homogeneous equation can be written in this form: y double dash plus f x y dash plus g of x y is equal to r of x. For example, in this expression, the right hand side is not equals to 0. The second order non-homogeneous can be written in this way. For example, 4y dash plus 2y is equals to y. The constant in this type of equation, the right side of the equal to sign, that should not be equals to 0. Then it is known as non-homogeneous differential equations. I hope you all guys have understood what is differential equations, what are the types, and the 6 types of these differential equations. I have not gone into the depth of these differential equations, and I have done only on surface, on the general, to know, to help you know guys what are the general way. So moving on to the next slide. This is the last slide that I will be discussing, and this is the summary of what we have discussed in this 50. I hope this is very clear. See, this Now I'm going to repeat this again. Ordinary differential equation. It is a differential equation that involves one or more ordinary derivatives but without having partial derivatives. Partial differential equations. Partial differential equation is a differential equation that involves partial derivatives. It has two or more independent variables. Linear differential variables. It is the first degree with respect to the dependent variables and its derivative that can be expressed in this form. Non-linear differential equations. Non-linear differential equation. It is a second degree or higher with respect to dependent variables and its derivatives. Homogeneous differential equation. It is first order differential equations which can be written as this. Non-homogeneous differential equation. It is a differential equation whose right hand side is not equals to 0. A second order non-homogeneous equation can be written in this form. Thank you. I hope you all have enjoyed my PPT. I hope it's clear, but it is I have shown this shown you these differential equations on not I have not gone depth to what actually these differential equations are, what are its problems, and how to solve them. Uh, it is a general view I have shown you. What I have shown in this video is the general view of what the differential equations are looks like. Looks like. So I hope it is clear. I thank you all to spend your valuable time in this listening to this PPT presentation. Thank you.